Assalamualaikum warahmatullahi wabarakatuh to our lecturer Dr. Idayunie. Welcome to our video presentation. So, today we are going to present on our findings about the project of the graph theory, which is designing a tree of notification for 5 selected residential areas in Kuala Muda, Kedah. So, let's get started. I had like to quickly introduce myself and my team members. Our team consists of 4 people from the class 6D. My name is Siti Nor Idayu binti Ramli. Other 3 people are Khairul, Nisha binti Khairul, Anuar, Nursyuhada binti Zulhasnan, and Idayunie binti Nording. We started preparing for this group project. We were suddenly reminded by the flood incident that just happened recently in a few states in Malaysia. We can see in news that many states have been greatly affected by the flood, such as in Kuala Lipis, Raub, Kuantan in Pahang, and also in other states such as Kedah. So, what is actually a flood? Flood is an overflow water that submerges land that is usually dry. There are a few factors that may contribute to the floods incident, such as heavy rainfalls, urban drainage basin, and also overflowing rivers. I had like to take this opportunity to design a tree of notification to notify 5 selected residential areas in Kuala Muda, Kedah about the flood. The goal is to notify the 5 selected residential areas with the shortest route and the cheapest cost possible. Therefore, it will ensure that the quickest notification will be done and the cheapest cost for all residential areas in Kuala Muda, Kedah district. The notification will be done by one person, and that person has to travel by car from Pejabat Daerah Kuala Muda to the selected 5 residential areas.
Assalamualaikum. My name is Khairul Nisha binti Khairul Anuar. Now I will present to you the table of contents of this project. First and foremost, we have list of residential areas, which have 5 residential areas and 1 district office. Next is we have the list of assumptions that have been used to get a better result. We also have list of routes that have been used in this project. Next, we also have adjacency metric of the total distance, and lastly, we have the result that have been generated by the Google Colab. Okay, firstly is list of residential areas. There are 5 residential areas and 1 district office. All the residential areas is located at Sungai Petani, Kedah. And we declare the district office is at Pejabat Daerah Kuala Muda. That is point A. Next is point B is Taman Sinar Intan, followed by point C is Kampung Teluk Wang Besar, and point D is Taman Sungai Jagung. After that is point E, Taman Seroja, and lastly point F, Kampung Haji Wahab.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nursyuhada binti Zulhasnan, and I will present the next slide, which are list of assumption and list of routes. We are using the traveling salesman problem. What is TSP? TSP is a classic algorithmic problem that focuses on optimization, which often related to cheaper, shorter, or faster solution. Usually, it is easily to express as a graph describing the location of a set of nodes. Firstly, we are assuming that a person will start travel from Pejabat Daerah Kuala Muda, and the person is using Produa might be 1.5 auto car that need 36 liters of fuel to fulfill the tank. The fuel use is $1.95, and every 1 liter is worth Rm 1.64. Every liter of fuel can travel for 20 kilometers per hour. One location to another do not involve toll. Besides that, one location to another, there is at least 1 route and the maximum is 2 routes. Since we are using TSP, the selected route is based on the shortest and the cheapest cost use. Here is the formula used to calculate the fuel cost and the total cost. Note that the total cost is equal to the fuel cost because there is no toll involved. Here is the list of routes and the total cost of the selected route. There are 15 possible destinations with 28 routes option. There are 2 destinations that only has 1 route option. The first one is from destination C to destination D, and destination D to destination F, while the rest are having 2 routes option. By measuring the distance from one place to another and calculating the fuel cost using the formula stated in the previous slide, we choose the shortest route and cheapest cost. This method will ensure the residential get notified very quick and less cost consuming.
Assalamualaikum warahmatullahi wabarakatuh. My name is Idayunie binti Nording. Today I will be presenting adjacency matrix and results. We generate coding using Google Colab, and as we can see in the slide, this is a table of distance matrix. Next, we insert the distance matrix into the coding in order to get the shortest path and the lowest total cost for 5 selected residential areas including district office that have been stated above. In the list of routes, we have specified the total cost for each selected route in kilometer, but in the distance matrix, we need to specify the total distance in meters. This is because coding cannot be carried out if the total distance is in the form of point or not integers. After that, the total distance that we get from the coding, we change the units again from meter to kilometer. Lastly is result. This is a network graph of 5 selected residential areas including district office. Based on the graph, we get the results, which is total distance, total cost, and suggested path. The total distance is 34.9 km and the total cost is RM3.21. Lastly is the suggested path. The suggested path for the shortest route based on the graph is starting from vertex A, which is pejabat daerah Kuala Muda, and also ended at vertex A. This satisfied the condition of this project, which require the starting point is district office. If we calculate manually the total cost and the total distance, we get the same result as the output of the Google Colab. That's all from us. Thank you.